pointer. And then we just say, instead of leaving it there, we say is native. And this thing here is a trait. And we can actually define our own traits. So this native call library provides this native trait. It then gets invoked as we're compiling this. And instead of, you'll see we just wrote a stub body here. This is actually really valid Perl-6 syntax, this ... What it actually does is it replaces the body of this sub with something that's going to call the C function MySQL real connect in lib MySQL client, and it marshals all of the arguments across. That means we can write database layers in pure Perl-6. And the beauty is that, if we ship this module, we don't need a C compiler to install it. It just works. Yeah.
I've been wanting that for 15 years.
Yeah, you have it now. And we actually have the MySQL database layer and the Postgres one written and using this. I've used it for Win32 API as well. So the next step for this is to start passing structs around and unpacking them, and also to get callbacks in place, and then we'll be able to write GUI apps in pure Perl-6 as well, which will be wonderful. Yes?
Are all of the big pointers interchangeable? Can you make them strongly typed so that you can't pass a MySQL pointer to Postgres function?
At the moment, no. That's why we need the compact struct stuff that's coming next. And once we get that, we'll actually be able to do those kinds of things. Opaque pointer is kind of we don't have all of the bits of Perl-6 we want, so here's a kludge that makes things work well enough for now.
White star.
Yeah. Yeah. But
I suppose it's really generic role.
yeah, we could do a generic role. Yeah, that would work. That would work. Yeah. So far I've been talking about captures and signatures, and we've always seen them attached to a subroutine. But actually what happens if we decide to take them away and try and use them? Because after all, if they're first-class objects, surely just because we can have one associated with a sub doesn't mean we have to. Well, one of the other places you can do this is you can actually unpack return values. So suppose I have some database layer here, and I make this call which, get the highest scorer from the database, and, in some game. Then, instead of just taking the object back, I can actually say, oh, I'd like to coerce the object into a capture and unpack the various things in it. So this might be an object with, .name and .score methods on it. Or it might just be a hash with name and score keys. It actually doesn't matter here. And the really, really important thing here is this: colon equals. This is not an assignment. This is a bind. And this is the really important difference here. If you actually went and wrote an equals there, it ain't going to work. That's going to try and do a list assignment. And it's actually going to tell you a compile time in this case. No, you can't do this. But this is going to just unpack the things, and then we have variables with the various bits from the hash or the object in it, so we don't have to go unpacking it ourselves later. And yes, you can write nested signatures in there and do whatever you like. The other thing that we can do, though, is start using signatures as a kind of tree matching language. Because if you actually think about tree data structures, we actually can then put nested signatures inside nested signatures and start digging down deeply into a data structure and seeing what's there. So in many senses, signatures, when you kind of start using them like this, are kind of like the regexes of trees. And to give you a kind of concrete example, so I work in the world of compilers, so an example from compiler development. If somebody writes, say, 24 plus 18 in their program, we'd really like to do an optimization called constant folding. And constant folding is where we actually go and compute this at compile time and just stick 42 into the program. Now, when we actually compile code like this, we actually compile it to these Perl-6 abstract syntax tree nodes. And we have various node types, and one of them, this top one here, is just a call node, and it says, I want you to call the infix plus operator. So all operators are just multi-dispatch subs. So operator overloading is another multi-candidate, but that's an aside for now. But then this thing has two children. So the two values, and these are value nodes. We have two of them. And what we'd like is just to be able to emit one node like this on the right-hand side. So what we want to do is be able to look at the tree, and we want to be able to say, whenever I see a infix op, that is say plus, minus, start, percent, and so on and so on, and I have some past value that is sort of an int or some numeric type, then I'd like to spot it, and I'd like to do some optimization work on it. Well, here's how we do it. We can have a given block, which is going to be taking the node that we're currently considering optimizing, and then we are going to write a signature. And if you want to write a signature somewhere other than a subroutine, then the trick is that you write a colon before it, and then parens. So anything colon, parens, and stuff inside it is going to be a signature. So the signature we're going to define here, we're going to say, I want to take something of past val, and then I want a nested signature here. I want to pull out the type, and I want to say I want it to be a numeric type. Numeric is a role that is done by int and brats and all of those kind of built-in numeric types. And then the star percent, it's a sluggy hash, but we're saying, actually don't bother capturing all of the things into a hash, I just don't care about them. We can do the same below. So here we say we want to match a second node, just exactly the same as the first. So here we've matched two value nodes. We're saying we want the type of the op node to be call. And then we just do a regex here. We're saying I want it to be an infix, and I want it to be, this is just a character class, plus, minus, star, or percent. And that's it. And then we don't care what else is in here. So essentially what we've done is we've just done a match against a tree using a bunch of nested signatures. And you can see then we can just go off and call fault constants like that. So then of course you can do a bunch of other things to do a bunch of optimizations. So essentially you kind of have a free bonus tree matching language out of signatures as well. And the reason this actually works is because when you smart match against the signature, because given when just sets for smart match, then it'll actually go and it'll actually try and say, if I coerce this to a capture, and actually past nodes already are captures, will it bind against the signature? So yeah, this is kind of neat.
Jonathan,
yes.
Can you go back? Is there an error in your range, or am I misunderstanding Perl 6? Should the minus sign be at the front? Isn't that plus?
No. We don't use dash for ranges in Perl 6. We use two dots, just like anywhere else in Perl 6.
Okay, thank you.
It probably requires a backslash to do
Oh?
for now.
Oh, because we give warnings.
Warning to people who are in Perl 5 who often mistake.
Okay. So in a perfect world in 10 years' time when we don't have to warn people, yeah, it might work. But yeah, I maybe should have backslashed that, I guess. But yeah, it's technically not needed. Yeah.
Tell me those aren't backwards. Tell me those aren't backwards.
What? I did type them as backwards.
Typographically, your file generator changes.
Thank you very much, PowerPoint. So I'd like to show you one last thing, which is actually from a module that I wrote called Test Mock. Test Mock was a quick hack, and basically it makes mock objects for you. We actually shipped it in Recruiter Star because it's a nice example of some stuff, but it's there on GitHub if you want to have a look at it. And I'm actually just going to show you how I used signatures and captures as first-class objects in here to kind of do some nice stuff. And actually let me write this test mocking framework in hardly any code at all. So how do you use it? Well, here I'm just going to define a class pub. It's got a method orderBeard, which is the most important thing you do in a pub. It's got a throw method as well. and then we're going to have a class and a party class and so on. So instead of just creating, a new pub object by doing pub.new, with this test mock module, I can say I want a mocked pub. And then I can just call a few methods on it. I can throw a party, I can order some beer, really not enough beer, but I can order some. So I write this code, and after I've done this, in reality you'd actually pass the mock object off to the code you wanted to test, but we'll just keep this nice and simple here. After I've done this, I want to do some analysis on the methods that were called, to do some tests. Well, to do that, I say check mock. This is just a sub that's exported by this test mock module. I pass in the mocked pub. And then I can start passing in closures which do checks. So in a really simple case, I can just say, oh, I want to know that I called the order via method, and I wanted to, I wanted to have called it 2 times. So that isn't doing anything particularly clever with captures or signatures just yet. But what if I actually want to care about the arguments that were passed? Well, I then have this with thing. And this with thing lets me pass in either a capture or a signature. And if I pass a capture in, and remember how I said that if you write a colon and then some stuff in parens, it's a signature, kind of literal, if you like. Well, the alternative for captures, when you're away from a subroutine, is just the backslash, and then the stuff inside the parens. So this is actually going to make a capture with just the argument 1 in it, and in this case the argument 2. So in this case we can say I want to have called it 1 time with the argument 1 time with the argument 2, and then here I want to have never called it with the argument 10. So this kind of gives us some flexibility, but not that much, because we might want to make some generalities about what was passed. Well, in that case we can just do signatures. So if I pass a signature object here, it's actually going to go and match the arguments that I passed when I called the method. It's actually recording all the stuff that gets passed, and then it's going to match the signature against it. So I can actually say, this test is going to pass, provided I call throw with something of type party, and it's going to fail if I actually call it with glass. And then we can actually start going into constraints as well. So I can say, I expect to have called order via 2 times, where I was passed a parameter that was less than 10. And I expect to have never been called with a parameter greater than 10, because if you're ordering 10 beers at a time, you're just clogging up the bar. How did I implement this? Well, this is the called method, and you can see at the top here, we just grep out, I actually have a log, an array of all the calls, which is just an array of hashes, and I grep out all the calls with a given name, but the real clever code is just this few lines here. And then I say if I've been passed a with, you can see I've got that $with parameter there. If I was passed this, if it's a capture, then I just like to grep out all of the calls where the capture is equivalent to the with. Otherwise, I just like to smart match the capture against the with. And if that's a signature, it's just going to say, could this capture have found the signature? That's the entirety of the logic for actually saying, for actually doing the check on our mock object to see if it passed what we expected. So yeah, by having signatures and captures as first class, we get all of this stuff pretty much for free. So some conclusions. So in a sense, yes, Perl signatures just replace your usage of @_. But actually that's just the start of what they do. And you can use them for unpacking data structures, you can use them for tree matching, and all kinds of things beyond just having them as signatures. When can you do all of this? In Rakudo style.